These angles are what, Malik? They are corresponding. Hold on. You know they're corresponding because they're both in the same location. They're both in the top right. Okay? If they're in the same location, then they're corresponding. Rebecca, how do we know they're parallel? The red arrows. Any parallel lines, they'll either tell you they're parallel, it'll either say P is parallel to Q, or it'll provide you with these arrows. And the same number of arrows implies that those lines are parallel. Very, very good. Today, we're going to be doing the exact same vocabulary. The only difference is, wait for it, I'm going to be telling you whether certain types of angles are congruent or supplementary. Now, if they're congruent, what do you think we're going to do with their pieces to solve mathematically today? Set them equal. If they are supplementary, what do you think we're going to do with their pieces? Add them to what? Okay. If you can get that, that is all the math we're doing today. Setting things equal, adding things to 180. Okay. Right! I'll come get them while you record postulate 15 in your notes. One second. Oh, this needs to go in your postulates and theorem section. This one does need to go in your postulates and theorem section. Yeah, I'm going to give you new ones. I'm going to come get you, John. Thank you. Thank you. All right. Now, here's the thing about these angles. Unless it looks like a right angle, because when it's a right angle, it's hard to tell what's the same, what's different. Look at this picture, okay? Every angle, if I were to point to an angle, ask yourself this question: could you tell me if it's acute or obtuse? Or are there any of them that you're not sure? If I pointed to any of the 8 angles up there, could you tell me if it's acute or obtuse? Here's the thing. I'm going to be telling you postulates and theorems to let you know, for instance, this particular postulate says they're congruent. But if what I'm about to say could literally power you through half of the next test if you scratch it. If 2 lines are parallel, that's the key to all of these, that they are parallel. If 2 lines are parallel cut by a transversal, there's only going to be one of 2 measures there, which means any 2 angles are either going to be supplementary or congruent. If they are both acute or both obtuse, they're congruent. If they look the same, they are the same. You know how I'm always like, you can assume. Well, if they're parallel, you can assume. These, do they both look acute? Do they both look obtuse? Or do they look different? They both look acute. They're congruent. What about this angle and this angle? Do they look both obtuse or both acute? Or if they both look like the same, what do you think they're going to be? So guess what? When we get to the alternate exterior angles theorem, they're going to be congruent. What about, let's see. I'm trying to think of one. What about this angle and this angle? This one acute or obtuse? What about this one? Are they different? Then they're going to be supplementary. If they look different, they're going to add to 180. If they look the same, they're going to be congruent. Now I'm going to be showing you, so you might be thinking, well, why do we have to write these down? Because proofs are coming. In Proofville, if I say, how do you know? You have to say, I know they're congruent by the corresponding angle postulate, which states, if you have two parallel lines cut by transversal, any pair of corresponding angles are going to be congruent with each other. Today, the problems you're going to have to say, oh, 2 and 6 are congruent by corresponding angles postulate. Now, you could do that one of two ways. You could just say postulate 15. I like to use acronyms. I like to name my postulate. So I always call this CAP, corresponding angles postulate. But how you do that is up to you. You could write it out every time if you wanted to. Alternate interior angles theorem. Yes, all of the theorems and postulates today need to go in that section of your notes. Now, while you're writing this, you could probably look at 4 and 5 and say, hey, those both look obtuse. Therefore, if they both look like the same thing, they are, big keyword, congruent. Which means if I were to give you like 4x and 120, what would you do with those two things? Set them equal. Anything that is congruent, you set equal. So, again, please notice, every single one of these starts with this. If the two lines are parallel. If they are not parallel, you cannot assume this. They may look parallel. They may look perfectly parallel. But unless they provide you with concrete news and evidence that these things are parallel, you can't assume this. But if they do, yes. Let me tell you, Tuesday, we're going to go over something so simple yet so complicated it's going to make your brain hurt. Tuesday, we're going to do literally this exact same lesson. But here's the difference. Tuesday, like what am I telling you today? Today I'm saying, hey, guess what? If you know two lines are parallel, then you know their angles are congruent. Yeah. Tuesday, I'm going to be doing just the opposite. I'm going to be saying, if their angles are congruent, then we know the lines are parallel. It's like, that's the same thing. But order matters when you start doing proofs. Like what came first, the chicken or the egg? Well, it depends on the problem. So, anyway, alternate interior angles are congruent. Questions about what that says? All right. You could probably go ahead and do the next two theorems just by looking at the picture, so I'll put them up here anyway. Alternate exterior congruent. Again, you don't have to write this down verbatim. You just wanted to write alternate exterior angles theorem, but the angles are congruent. As long as you know what alternate exterior angles are, that's probably enough to know what this says. Two lines that are parallel, cut by a transversal, the alternate exterior angles will be congruent. Last but not least, the last one. Consecutive interior angles theorem. It's the only theorem where I'm giving you supplementary. Notice, one's acute, one's obtuse, therefore they are supplementary. And that same whole, hey, you can probably look at it and figure out which ones are the same and different, that goes for linear pair and vertical angles too. If you were to look at just one intersection, you could figure out which ones were the same and which ones were different. Everything after this is examples, that we're just going to look at example after example after example until we're confident in what we're doing. I don't think there's any more notes. I don't think so. While you're writing these, quick raise of hands. Who thought that using your notes on your last test actually helped? Raise your hand if you really didn't ever really even need your notes or use them. Oh, so you did think they were helpful for the most part. Most of you, anyway. Well, that's good. Good. Okay. Are we done with the slide? Okay. How about now? All right. The measure of three of the numbered. Oh, excuse me. The measure of. Yes. Identify the other 56-degree angles. Who can look at this picture? Now remember, if they look the same. Oh, it didn't tell us they were parallel, did it? Darn it. I may have cut off part of the directions. I think I did. These lines are parallel. I apologize if I cut off part of the directions. Look, arrows, parallel. Just without even using your theorems and postulates, looking at which angle is 56, please tell me what other angles are 56. Yes, ma'am. You're exactly right. How did you know that? Very good. They look the same. They're the acute ones. Who could tell me what angle 2 would be? They're either going to be the same or they're going to add to 180. So if it's not the same, subtract from 180. What is angle 2 going to be? Yes, sir? It is. And what is that? What did you say? 124. What other angles are going to be 124? 4, 6, and 8. Very good. Very good. Now, here's where it might be a tad tricky today. You have to explain how you know that those angles are what they are. So here's what you're going to have to do. This actually said, which angles are 56? So, first thing you do, angle 3 is one of your answers. How do you know that? What piece of vocabulary are 56 and number 3? It won't be something you did today because it's only on one intersection. What kind of angles are those? Oh. That piece of vocab, but it was the other one. Vertical angles. These two are vertical angles. So, angle 3 by the vertical. Oh, have I taught you that thing? Well, you can just write the vocab. They are vertical angles. What was the other one? It was angle 5. What kind of angle is 5 with this one? Yes. Therefore, which postulate or theorem are we going to use? Very good. The corresponding angles postulate. You have to write these today. How you know. Let's see. What's another? Now, if we had already found angle 3, what's another way, if we already had angle 3, that we could have concluded that angle 5 was the same as the other two? What's another way we could have done it? Hence, you wrote it down in your notes a minute ago. I think it was the second one. Just blurt it out. If we know this one's 56, these two are alternate interior angles. and therefore are also congruent in your notes. So that's another thing you could have listed. And last but not least, angle 7. How did we know angle 7 was 56? I'm sorry? That's one thing you could have done. It's vertical with 5, assuming you've already shown 5. What's something else we could have done? Alternate exterior with our original. And since I'm going to just bounce everything off our original, so I'm going to write that one. But both of those would be right. And what's another one we could have done? Corresponding, because we've already shown that this one is 56. There are options here. Well, it didn't take, I mean, it's not like lengthy. You have to think about it, though, yes. Darn them. Let's look at another one. Okay. If angle 2 is 65, find 3 other angles that have a measure of 65 and explain your reasoning. So, this one is 65. We're going to go around the room. Everyone's going to have a turn to answer today. I'm going to start in this corner. Everybody's going to answer, and we're going to make the rounds. We have lots of these to do. So, what's one of them that we can say is congruent to 65, Sage? By what? How do you know? Like the last one. Yes. By the way, again, they've got 2 of these parallel. But I'm asking for concrete reasons. What kind of angles is... Oops, wrong direction. What kind of angle is 8 with 2? If you're only using one intersection, that has to be linear or vertical. There you go. Vertical angles. And I'll tell you right now, I don't know how we missed it, but that's actually a theorem, the vertical angles theorem. All right. Andrew, what's another one that is 65 degrees in this picture? By what? How do we know? There's 2 things you could choose now because she's given you this one. You can compare it with this angle or this angle. What kind of angles are these? Like vocabulary-wise, what kind are they? There you go. Here's, when in doubt, just name the angles and throw the word theorem after it. And you're right. Alternate interior angles theorem. And you're correct. The only one that's not a theorem is corresponding. That's a postulate. And I can explain. Here, just briefly, here's why one of them is a postulate and the other one's not a theorem. They have... You know what? That's what we'll start with Tuesday. Let's not worry about that right now. Okay. Brandon, what is the last 65 degree angle? There you go. The corresponding angles postulate. Very good. Okay. We're going to go ahead and do number 2. Jensen, what is a 115 degree angle in this picture? And how do you know that? Okay. Okay. And how do you know that? Logically, you're right. But can you tell me any kind of relationship it has with one of its neighbors? It's a piece of vocab. Your only options here are these. You don't know this one, so you can't use corresponding. Okay? You don't know this one, so you can't use alternate exterior. And you can't use consecutive interior because they're not next to each other. So your only option right now is to use either vertical angle, which you don't know because you don't know this one, or a linear pair. Do you? What is a linear pair of angle 5? Which angle would form a linear pair with that? 4. There you go. There you go. This is 115 by the linear pair postulate. I apologize again. You might have to write these acronyms down if you want to, you can write it out. But the linear pair postulate. These are a linear pair, therefore they are supplementary. All right, Stacy. What's another? 115. By what? There you go. Vertical angles theorem. Trip, what's another 115? There's only two angles that aren't labeled. It has to be one of those two. And how do you know? Boom! It is alternate interior with angle 3. 115. Sorry, that's kind of messy. 15. By the alternate interior angles theorem. Last but not least, who do I want to pick on? Which one of you two wants this one? The next person can start the next lesson. Go for it. What's the last one? And how do you know? That'll work. It is alternate exterior with which angle? Which angle is this one alternate and exterior from? There you go. You're not a setter. Okay. Here we go. Questions on any of those? Find the value of x. Rachel? How do I know what to do with those angles? What types are they? Just tell me that. They are acute. And corresponding alternate interior, alternate exterior, or consecutive interior, what are they? Yes. And in the alternate exterior angles theorem, it says that those two angles should be what with each other? So therefore, what do I do? If they're supplementary, you add them. If they're congruent, there you go. Set them equal. X minus 8 equals 55. Add the 8. X equals 63. Oh, this X equals 63. Questions? We have a lot more examples, so I'm still going to get to everybody. If things are congruent, you set them equal. Here we go. All right. Back up. What kind of angles are in this picture? That one. Yes. You're right. Corresponding. Therefore, because they're corresponding, I do what with them? Set them equal. 4x, dadgummit, 4x equals 48. So what's x going to be? No, I don't care. Anybody can answer that. Malik, what's x going to be? What's x going to be here? 4x equals 48. What will x be? There you go. All right. Jasmine, you think you want to tackle one? No? Now, this next one is trickier. You don't have a theorem for that. You can't assume that. You can't assume that. But now look, we do not have a theorem that links this angle and that angle. You can't use anything directly. But couldn't I easily figure out what either of these angles are and then link that one using one of our theorems of possibility? So how about this one? What is this angle going to be? This is a two-step problem. No, it's not your turn. That's your turn. Jasmine, what is this angle going to be measure-wise? Well, they're not congruent, therefore they have to be, big S word, rhymes with supper, supplementary. Therefore making this what? 180 minus this is, you can use a calculator. 77. Now, these didn't. You are going to have homework problems. You have to explain every step. It's not that hard. All you have to do, you know this is 77. What kind of angles are these? They are. When I say what kind, I'm looking for vocabulary. They are supplementary. They are a linear pair. So, that's 77 by the linear pair postulate. Now we're going to loop around here. Elon or Ariane, you can finish this up. How do I know what to do with these two? How? What kind of angles are they? Corresponding angles postulate says they're congruent. Therefore, I can set them equal. So that's 14x equals 70 after you subtract. Divide by 14. And beat me to it. There you go. Elon! Ooh. Now, same vocab, but the picture kind of looks funky because it's turned sideways. Can you fight through that and tell me what kind of angles these are?
Those are alternate exterior.
Yes, you can. They're all alternate exterior. Justin, if they're alternate exterior, what do we do with them? Set them equal. Because alternate exterior angles are congruent. Yes, Blake, tell me the answer. Ooh, second-hand answer. Okay, Elijah, a hard one's falling on you, buddy. Because you do not have anything that links these two kinds of angles. If you search through your notes, you don't have it. But you have so many options. You can take a linear angle here. You can take a linear angle here, and then alternate exterior, corresponding, either way. So, if we use, I'll help you with the first step, the linear pair postulate, what would either of those angles be? Measure-wise, you can use your calculator. I don't need the whole answer. I just need what would one of these be? You know, what would these add up to? Let me ask you this. Does that form a straight line? Straight lines have how many degrees? There you go. And if this is 135, what's the other piece? Minus that. So what would it be? 45. And I'll do it with this angle. So, if that's 45, Donovan, what kind of angles are these? Alternate exterior. And Caitlin, what do I do with alternate exterior? Set them equal. And if I set them equal, what's that going to give me, Cameron? If I set 45 equal to 4x minus 3, Cameron, what will that give me for my x value? So here's where we are. We set 45 equal to 4x minus 3. Add the 3, divide by 4, what do you get? There you go. There you go. No, well, you know what? You know what? I'm going to make these bonus. I'm going to make these bonus. Hold on. We're going to call those your problems. However, there you go. If you did not do well on the last test, this is a chance for you to make some of those points back. 28 through what? Dude, I am so far behind on my grading. That's very thoughtful. No, I'm still working on them. I got through half of them yesterday. 28 through 32 are bonus.